Hi, I'm Ridley of Ridley Engineering, and welcome to part 2 of our video series on frequency response analysis. In part 2, we're going to look at the measurement frequency range that you need for switching power supplies. So our range of frequencies is quite extreme, as we're going to see here. And when you're going to invest in a frequency response analyzer, you want to make sure it's going to do everything. You don't want to invest some money and find you're missing something on the low end or the high end of the range. So when we look at the frequencies we will need for switching power supplies, we're going to do, if you're going to be switching power supplies for your career, you're going to need to measure and build and measure power factor correction circuits. And when we look at power factor correction circuits, they're quite interesting in that their control loop actually crosses over at around 1 Hertz. If you go any higher than that, you'll find that you get distortion on the input current. So the first frequency we point here is 1 Hertz is a power factor correction loop gain crossover. So you want to make sure that you can capture that. Now if you want to see a loop gain associated with the power factor correction circuit, you're going to have to go either 1 decade or 2 decades below the crossover frequency, and that's where you're going to start your loop gain of your frequency response analysis. So that's power factor correction circuit. Now when we do regular switching power converters, we almost always start our loop gain right here at 10 Hertz. Why 10 Hertz? Well, it's below the line frequency of 60 Hertz or 50 Hertz and its harmonics, and we want to make sure we've got plenty of gain at those frequencies so that we get good noise rejection at the output of the power supply. Line frequency harmonics, they start at 50 or 60 Hertz, and you can see they fall off with frequency as you generate third harmonics, fifth harmonics, etc. And all of these harmonics can affect the performance of our power supply, and we want to make sure we've got good gain in this region when we're measuring the loop. Next thing we run into with switching power supplies are the filter resonances, and they're typically 1 or 2 orders of magnitude less than the switching frequency. So they can range anywhere from a few hundred Hertz out to 5 kilohertz, sometimes even as high as 10 kilohertz. You can have a broad range in there depending on the switching frequency of your power supply. The loop gain crossover of the power supply is typically 10 kilohertz or less for most production supplies. That would be supplies which are switching at 100 or 200 kilohertz. And you'll find that most manufacturers don't get that aggressive in this loop gain crossover frequency. But as we're going to see later in this video series, the higher you make that crossover frequency, the better performance that you can get from your system. Switching frequencies today, they range anywhere from 20 kilohertz, which is the threshold of human hearing, up to several megahertz. But most production power supplies you'll find are still centered around 100 kilohertz. It really hasn't changed very much in the last 20 years or so. As we go up to the switching frequency, you can see this is our complete range of control frequencies, starting with the loop gain of a power factor correction circuit and ending, I usually stop at twice the switching frequency. So on our plots we can see where the switching frequency is, and we make sure we go beyond that to capture all the control information. So that's our control, and going beyond that we're going to see more things happening because we see EMI due to the switching frequency of the power supply, and it will kick up harmonics really as high as you want to go measure them, 100 megahertz or into the multi-gigahertz range if you want to do radiated noise of switching power supplies. We also see transformer resonances and ringing in our power circuits that we have to measure and characterize and design around. So it's very important when we have a frequency response analyzer that we can pick up the characteristics of our magnetics here, because that will enable us to do the snubber design of the circuit. So to conclude here, our frequency range goes from in excess of 10 megahertz all the way down to 0.01 hertz. And that is, how many decades is that? That's 9 decades of frequency that we have to track with our frequency response analyzer and doing frequency response analysis of our circuits. Just a summary there, this is switching EMI, these are the control frequencies that incorporate that full range. If you've enjoyed watching this video, please go to ridleyengineering.com and visit our design center there where you'll find many design tips for switching power supplies. Thank you for watching.